Today's lesson is about solving trig equations with a double angle. First of all, let's go over double angle identities. We have sine 2 theta equals 2 sine theta cosine theta. This is easy to remember. For cosine 2 theta, you have 3 formula. Which one you got to use? Normally, for trig equation with double angle, we use these two. So how to remember these two? First of all, cosine squared theta plus sine squared theta, that's equal to 1. And a cosine squared theta minus sine squared theta, that will be cosine 2 theta. We call this is a double angle. So when we double cosine squared theta, we got the 2 cosine squared theta. Then you change this one into 1. So minus 1. That's you got the cosine 2 theta. If we want to double this sine squared theta, then you have to change cosine squared theta into 1. That's how you get the 1 minus 2 sine squared theta equals cosine 2 theta. When you're working on trig equation with a double angle, remember this is the rule, the same angle, the same trig. 2x and x is not the same angle. So you have to change into x. The angle is x, not 2x. And also the same trig. That means try to change both cosine or both sine. For sine 2x, there's no other choice. We have to use this. So we got the 2 sine x cosine x. Then we plus sine x equal to 0. We have to do common factor. So sine x is the common factor. We got 2 cosine x plus 1 equal to 0. So we set up sine x equal to 0 and also 2 cosine x plus 1 equal to 0. For sine x equal to 0, reference angle, that's 0. So we got 0 and a pi will be our solution. x1 equals 0, x2 equals pi. For this equation, we have to isolate the cosine x first. So you minus 1 divided by 2. Therefore, cosine x equals to negative 1 over 2. Reference angle, that's pi over 3. So we go to this diagram. We know for cosine is less than 0. That means go to second and then the third. Reference angle is pi over 3. Therefore, we got 2 pi over 3 and 4 pi over 3. Check the angle here, that's x. So we can just write down x3 equals 2 pi over 3 and x4 equals 4 pi over 3. For part of 5, we need the angle between 0 to 2 pi. We don't have to get the general form, so this will be the solution. Now let's go to B. For sine 2x minus 2 cosine x equal to 0. Check the angle is different. That's why you have to use double angle identity changing into the same angle. So we got the 2 sine x cosine x minus 2 cosine x equal to 0. Common factor will be 2 cosine x. So we got the sine x minus 1 equal to 0. 2 cannot be 0, so you have to set up cosine x equal to 0 or sine x minus 1 equal to 0. For cosine x equal to 0, we got the reference angle equals pi over 2. Pi over 2. So the other angle will be 3 pi over 2. So we write down x1 equals pi over 2, x2 equals 3 pi over 2. For this part, you add 1 both sides, you got the sin x equals 1. So x equals pi over 2. Because this is the maximum value, that's why only one solution. We already got the x1 equals pi over 2. So we have two solutions. That's pi over 2 and 3 pi over 2 for B. Now let's go to D. For cosine 2x equals cosine x. First of all, you have to decide which formula you got to use. Since we have cosine x already, this one give you a clue you have to use this formula. So you get the 2 cosine square x minus 1 equals cosine x. This is a quadratic pattern. You have to set up equal 0. So move cosine to the left side. You will get 2 cosine square x minus cosine x minus 1 equal to 0. You have to use ninja x. That is negative 2, negative 1 over 2 over 2. So for negative 2, you got the 1 times negative 2. Adding is negative 1. This is the answer. So we got the 1 and a negative 2. Reduce negative 1 over 1. Then check the variable. For the variable, we have a cosine x. So we write down cosine x, cosine x. We do bottom up. You will get the 2 cosine x plus 1 times cosine x minus 1 equal to 0. Therefore, we set up 2 cosine x plus 1 equal to 0. And also cosine x minus 1 equal to 0. We go to linear pattern equation this time. Minus 1 divided by 2. So we got the cosine x equals negative 1 over 2. Reference angle, that's pi over 3. Go to which quadrant? That's less than 0. So second and then the third. You will get 2 pi over 3 and 4 pi over 3. Check the angle here, that's x. So we write down x1 equals 2 pi over 3 and x2 equals 4 pi over 3. For this equation, you have to add 1 both sides. You got the cosine x equals to 1. That's x equal to 0. So we can label this is a 3. We got the x1, x2 over here. Let's go to F. Cosine 2x minus sin x equal to 0. First of all, we already got the sin x. We try to get the same trig. That's why for cosine 2x, you have to change into this form. You will get 1 minus 2 sin square x, then minus sin x equal to 0. We don't want the coefficient before sin square is a negative. That's why we change the sign for everything. Then rewrite 2 sin square x plus sin x minus 1 equal to 0. Then we have to go to ninja x. Here's negative 2, 1 over 2 over 2. So for negative 2, I can do 1 times negative 2. but we're looking for positive 1. That's why I do the positive 2, negative 1. Positive 2, negative 1. Don't forget reduce. You will get 1 over 1. Check the variable. That's sin x. Sin x. Therefore, you will get sin x plus 1 times 2 sin x minus 1 equal to 0. So we will set up sin x plus 1 equal to 0, or 2 sin x minus 1 equal to 0. For both linear pattern, we isolating, we got the sin x equal negative 1. This is a minimum value. So x equals 3 pi over 2. For this one, I got the sin x. I add 1, then divided by 2. That's 1 over 2. So you have to get the reference angle equals pi over 6. Since this is a positive, we go to first and then the second. The value will be pi over 6 and 5 pi over 6. Check the angle. That is x. Therefore, we can get the x2. This is x1. Then equals 5 pi over 6. x3 equals pi over 6.